All right, so guys, we're going to go ahead and get started. I don't know that this is necessarily necessary, but I know that some of you are really coming to depend on this calendar as a way to stay organized. And so it always crosses my mind to at least go over the calendar at the beginning of a unit. It sort of gives you a sense of what the unit looks like. Certainly we'll get into more details later, but we can at least talk about it now. So guys, what we're going to do today is actually an activity. It takes about 6 minutes to introduce this to you. And then guys, you're going to be working on this for the rest of the day. That'll give us a chance to talk, things like that. So guys, today we're going to start with an activity. Then when we come back after the weekend, it will be our first day of new information in this unit. Coming back on Thursday, remember the replacement test is Thursday, and we're going to further dig into the material that we started on Monday. Then guys, in the days before Thanksgiving, we are actually going to do a lab. It's a lab that we always try to fit in right before Thanksgiving. It's a great transition into Thanksgiving break. It's a great day. If you're leaving early for Thanksgiving break, guys, this is also something that is easily done at home. And so you'll see, if you're going to be gone, it's not a bad day to miss, but certainly it's a great time to be here. Then guys, coming back after Thanksgiving, before Thanksgiving, it's all introductory stuff. Then after Thanksgiving, we're going to really start to dig into what are called LDMSs. You'll notice that it sounds like LDSs only with an M. So you guys, on the test, you learned how to do Lewis dot structures for atoms. These are Lewis dot structures for molecules. You're going to like it. Then guys, coming back into December, amazingly enough, early December on the 3rd, we're going to break out model kits, and we're going to figure out what these molecules actually look like three-dimensionally. But guys, on Thursday, it'll be me mucking around with the model kits. Then on Monday, it'll be you guys mucking around with the model kits. And then guys, our second and final test for second quarter will be on the 10th. Then guys, coming back into that last week before the end of the calendar year, we're not yet sure what we're going to do. On the 17th, we're going to do another lab, and that will be the end of our year. It's amazing to think that we're already thinking about the end of second quarter. So guys, we have one more unit to go, just to give you a sense of where we are. And so guys, we're going to dig in. So do not write any of this down, but let me explain to you what we're going to do today. So guys, you've got that graph paper in front of you, right? So guys, what you're going to do today is you are actually going to take this piece of graph paper and you're just going to lift some information off the periodic table and you're going to graph it. So guys, grab your periodic tables. You want them out of your binders. And guys, I want to explain to you how you're going to approach graphing this data. So guys, looking at the graph paper that you have in front of you, let me just give you a second to sort of familiarize yourself with it. Get a sense of what's going on. Maybe try to make some connections with the periodic table. Then we will talk about the ideas on here that are new to you, and then we'll get you to work. So guys, looking over this graph, what of the information that's referenced on that graph was familiar to you? The atomic number, right? So guys, if you look at the x-axis on this graph, you will notice that you are going to be plotting atomic numbers, and you'll notice that you're going to go 1 through 36. So guys, which is element number 1? Hydrogen. And then element 36 is krypton. So guys, what you're going to be doing is you are going to be graphing information about elements 1, hydrogen, through 36, krypton. And so you're only going to be looking at this portion of the periodic table. So then guys, the question is this: what are you going to be graphing? And so I would encourage you to write this down with me just so that you've got sort of a reference on this, because I want to show you literally what you're going to be graphing. Because what you're going to do is you're actually going to create two graphs on the same page. So gang, over here on the left, the thing that you're going to be graphing is atomic radius. Let's draw and make sure you understand. If you want to do this, you can. If not, I'll bet you can figure this out. So guys, if this is a circle, where's the radius? Where's the radius? Oh, please tell me you learned something on the south side of third floor. Yeah. From the center to the outside. Are we all in agreement that that's the radius? Okay, so now instead of a circular radius, let's make this an atom. So guys, what's in the middle of an atom? The nucleus. And what do we call the electrons on the outside of the atom? Valence electrons in orbitals. So guys, when we talk about the atomic radius, we are talking about the distance between the nucleus and the valence electron cloud. So it's literally the size of the atom. Well guys, if you take your periodic tables, Tori, you got to hold still, girl. If you take your periodic table and if you flip it over, which I hope you just did, guys, this information is on the back of your periodic table. Go down to the lower left-hand corner of the page, and you'll notice that there's a key down in that lower left-hand corner. And then, guys, find atomic radius. But be careful, because you'll notice that there is also a covalent radius that is listed there. We'll talk about covalent radius next week. Guys, today what you need is atomic radius. Did you all find it? You okay? So guys, the atomic radius is the bottom number in the red box in the upper left-hand corner of each of the cells. And so guys, these are the numbers that you're going to be graphing, and the units are angstroms, which are 10 to the negative 10th meters, really, really small. But guys, you're going to be graphing that piece of data for the first 36 elements. And then you're going to connect your dots. You get the idea? Okay, then guys, once you're done with that, you are going to completely start over in a different color. So guys, one of your colors could be pencil, one of them could be a pen. If you have the ability to write in multiple colors, that's great. If you don't, do it at home. But guys, I would encourage you to plot your points in pencil first, and then go back and go over them in color in case you need to move them. So guys, the next one that you're going to do is electronegativity. Guys, electronegativity is defined, and you may want to write this down. Guys, electronegativity is defined as an atom's stealing power. Stealing what? Well, stealing electrons. And guys, you're going to find out that when atoms bond together, what they're actually doing is wrestling over electrons. And electronegativity is like their wrestling power. We'll dig into that more later. But for now, what I'm going to ask you to do is graph it. So guys, find electronegativity on the back of your periodic tables. Do you see it there in the upper right-hand corner? Guys, first thing you'll notice, there are no units. Electronegativity is a dimensionless number. There are no units for electronegativity. They're only comparative in nature. But guys, the other thing I want you to notice is this. What is the electronegativity for helium, element number 2? What is it? Do you have a number? It's a dash, right? Guys, please do not confuse dashes with zeros. 0 is a number. Dash means it has no value. So when you're graphing electronegativities, if the electronegativity is a dash, do not graph that as 0. Skip that point. Does that make sense? Make sure you hear that, guys, or your graphs are going to be a train wreck. So guys, when you're graphing electronegativity, if there is not a value, do not interpret that to be 0. Leave a discontinuity, a break in your graph. Go ahead, Sam.
Are we graphing these from left to right, both of them?
Yeah, so what you're going to do is you're going to go helium to krypton. And the first time you're going to graph atomic radius using this scale, and then the second time you're going to graph electronegativity using this scale on the same graph. Is that okay? Okay. So guys, that's any questions about the graphs you're going to produce? You okay? Okay. Then guys, following that, the question is, why are we doing both of these graphs on the same table? And guys, the answer is because there's lots of interesting relationships that this brings up. And so guys, what you're going to be doing then is you're going to be answering these 4 questions. I like that you flipped it over to look on the back. But guys, here's the deal. After grading your flame test labs, and this is general, some of you did fine, but guys, remember when you went to turn in your flame test labs and I said, hey guys, keep them for another couple days because some of you don't understand that we write well in this class and we're going to write incomplete sentences, and some of you did great. And then some of you turned them in and they're still chicken scratched. So guys, we are going to answer these questions on another sheet of paper. The hope is that if you have lines and if you have space, that helps you better structure your writing. But guys, the idea is this. On a periodic table, this is instructional, periods are the horizontal rows. So guys, this is period number 1, this is period number 2, this is period number 3, and this is period number 4. So on the periodic table, periods are the horizontal rows. The first thing you're going to do is carefully draw vertical lines on your graphs separating the periods. Guys, rulers are here. Do a good job with these graphs, and you will be connecting your points as well. Then guys, on another sheet of paper, you're going to answer these 4 questions in well-developed, thorough answers. And all of this will be due when I see you on Monday. You'll staple your answers to your graphs, and we'll turn them in on Monday. You guys get the idea? Okay, so guys, rulers are here. Do great work. Make sure after you plot your points, you're connecting your lines. And by the way, guys, if there's that discontinuity, that break in your electronegativity graphs, don't connect the lines around it. Let there be a gap in your graph. That's going to be important. So if you have no value, leave a gap as you're connecting the points. So guys, I'm going to ask that you please stay put when you work on these. We're going to continue to do what we can to try to spread out a little bit. I just found out, did you guys know Skyridge actually tanked? Are you guys aware of this? They've set a new standard. They are now more than 1% of their student population is COVID positive. So they are now on a blended modified schedule. So they're on the AKLZ schedule, and they have Wednesdays off. So guys, literally, you have class once a week. So like teachers see their students once a week up at Skyridge. Let's do everything we can to avoid that. So guys, we're going to stay put. If you need a ruler, you do need rulers, come grab them. And the rest of the time is yours to knock these out. Anything you don't get done will be homework. So guys, go get them.